Objects and people in low Earth orbit can travel around Earth in an astounding 90 minutes.
45 minutes on the sunny side of Earth, 45 minutes on the dark side of Earth.
Houston, you're go for landing, over.
Except for a few trips to the moon, all of humankind's visits to space have been to low Earth orbit.
The bottom line in low Earth orbit is if you can't reach it, you can't go anywhere else. And human spaceflight ultimately is about going somewhere else. Low Earth orbit is kind of the entry point for that effort.
Above low Earth orbit is a region called medium Earth orbit. This wide stretch of space is 1,200 to 14,000 miles above Earth. Many communication satellites are launched into orbit here, including global positioning satellites.
GPS satellites roughly orbit the Earth at about 12,000 miles, what we call a semi-synchronous orbit. So basically, they orbit the Earth twice per day, once every 12 hours. GPS is set up into 6 orbital planes. So if you can imagine a globe, there are 6 orbits positioned in equal spacing around the Earth, with roughly 4 or 5 satellites per orbital plane. And basically, that gives us coverage around the world.
GPS satellites sit at this altitude so that multiple satellites are in view from one location on Earth at any time of day.
It takes 4 satellites to get you your exact location. The first will give you a roundabout area, the second will refine it, as well as the third, and finally the fourth says you are exactly here.
Medium Earth orbit is also home to the treacherous Van Allen radiation belts. These belts of high-energy charged particles can send a $300 million satellite spiraling out of control, or give a human being a fatal dose of radiation. These belts stretch out from Earth like elongated rings. Satellites are carefully placed in specific altitudes to avoid these destructive belts of particles from the sun. Even farther out lies high Earth orbit, or geosynchronous orbit. If low Earth orbit is a busy city, high Earth orbit is rural farmland. 22,000 to 35,000 miles above sea level, satellites hover above Earth, taking in an unparalleled view from a distant vantage point. Here, over 2,000 satellites call high Earth orbit home.
These satellites appear to be stationary. They make a circuit around the Earth every 24 hours, but so do we. So we have the optical illusion that these satellites are sitting there in outer space.
But in order to reach Earth orbit, an object must first leave the ground and be delivered into space. To do this, a rocket or spacecraft needs to achieve the appropriate speed and hit a target direction and altitude. Go even a few miles per hour too slow, and the forces of gravity and drag of the atmosphere will pull a spacecraft down, crashing it to the ground.
So the idea is to get out of the drag of the lower atmosphere, beyond all that turbulence and friction, and then start racing for the right direction and speed after you get up above the sensible atmosphere.
And there's a very good reason why spacecraft launch straight up rather than at an angle like an airplane.
So what typical space launches do is go straight up through the atmosphere to get through the thickest part initially, and then they begin to arc over a few miles up and then start to increase their velocity in the desired direction.
To reach a target orbit, a spacecraft must travel 17,500 miles per hour and follow a specific trajectory from the ground to desired altitude. Even 1 degree off, and a spacecraft will end up in the wrong orbit. After an 8-minute ride and millions of gallons of fuel burned, a spacecraft is now in orbit. An orbit is a reoccurring path around another object. Like Earth revolving around the Sun, a satellite or spacecraft is held in orbit by gravity. Earth's mass creates a gravitational force that deflects an object's path from a straight line. it might be assumed that Earth's gravitational pull loses much of its influence this high in the sky. But in low Earth orbit, Earth's gravity is only 2% less powerful than it is on the surface of the planet.
The way you stay in orbit is to go at a high enough speed or velocity that you are falling back to the Earth, but you're going so fast that your curved path actually never strikes the curved surface of the Earth. You just keep falling around the world over and over again. So you're not leaving the gravity behind, but you're being spun around the planet by gravity. It's what's holding you in this circular path around the planet, and it's making you fall back to Earth.
In theory, objects can stay in orbit forever, as long as they have enough speed to resist the pull of Earth's gravity. There are two types of orbits, circular and elliptical. Circular orbits are for satellites or spacecraft that need to maintain a consistent altitude and travel in a regular circle around Earth. Mapping satellites, GPS, and weather satellites all use circular orbits. Elliptical orbits are oval in shape. They're used when a high altitude is needed for part of the orbit, without having to go all the way to high-altitude circular orbit. Spacecraft delivering satellites into high orbits use elliptical orbits to deliver their payloads. Whether traveling in a circle or an elliptical path, there are many things in Earth orbit that are dangerous. In October 2007, the U.S. Navy shot down an out-of-service satellite with a cruise missile before it re-entered the atmosphere. The reason? The satellite carried hazardous material on board, and had it crashed to the ground, could have poisoned thousands.
That hazardous material was 1,000 pounds of hydrazine, which is a standard propellant.
The operation was called Burnt Frost, and it was the most elaborate effort thus far to protect the world from a serious yet growing problem called space debris, or space junk.
Space junk is anything that's man-made that was put into space and is no longer functioning. Oh, we've got junk that's been up there for as long as we've been in space.
Like a junkyard slowly becoming cluttered with debris. From the first launch of Sputnik in 1957, debris has steadily been accumulating around planet Earth.
50 years into the space race, we have littered the heavens with our garbage.
And now, about 20,000 pieces later, Earth orbit has turned into a deadly debris-filled junkyard.
It looks like the Earth surrounded by a hive of bees.
Most of the space debris includes shards of rockets, satellites that no longer function, or pieces of an object that have broken up after a launch. Caught in Earth's gravitational pull, these pieces are traveling upwards of 22,000 miles per hour.
Say more than 10 times faster than a bullet.
A collision between functioning objects such as satellites or inhabited spacecraft and space junk could be catastrophic. The Joint Space Operations Center, or JSPOC, is a top-secret Air Force surveillance unit that makes it their business to track every object that orbits around Earth, including space debris.
We use a number of different sensors around the world, known as the Space Surveillance Network. It's a network of 29 stations all around the globe, radars as well as optical telescopes that track over 18,000 man-made objects in space. And that includes active satellites as well as dead satellites, and then rocket bodies that were associated with those launches, as well as debris, things that have just shed off. If they were to run into each other, it really would be a catastrophic conjunction.
To be tracked by JSPOC, debris must be at least 2 inches wide. There are much smaller objects that cannot be tracked.
On most of my shuttle flights, we always saw small pits in the windows about the size of a pencil point.
The highest population of debris are in low Earth orbit.
And in 2008, an intentional collision between 2 satellites created an international outrage and a cloud of debris that threatened low Earth orbit like never before. Our edge of space is Earth orbit, a new frontier for space tourism and exploration. But danger lurks here, space debris, and it threatens our spacecraft and satellites like never before. In 2007, the total estimated amount of space debris was 20,000 pieces, 14,000 of which were trackable. Then, in 2008, China's space program intentionally crashed 2 satellites together as an anti-satellite test. The international space community was outraged.
The 10th of January of 2007, the number of objects we were tracking was less than 14,000. Here we are 16 months later, and we've increased that number by over 30% to over 18,000.
The problem of space debris continues to grow, and collisions have already occurred between space junk and functioning objects.
One of them was a piece of debris that struck a gravitation boom on a spacecraft, severed the boom.
To avoid future collisions, JSPOC is in constant contact with NASA and other international space entities to inform them when a spacecraft or satellite might be threatened, so that the spacecraft could be maneuvered around the space debris. Much like a boat maneuvers around hazards in a waterway.
Beneath the surface of the water here, what you can't see is what's going to actually give you the most damage if we run into a log or a snag beneath the surface. And in orbit, that's the same problem that we face. We don't track all the debris that could actually cripple or kill your spacecraft. And we rely on the fact that you're just statistically unlikely to hit a piece of debris to protect you. And that insurance policy is going to run out someday.
Fortunately, there haven't been any catastrophic collisions between inhabited spacecraft and space debris, yet.
We've never seen a human-piloted spacecraft run into orbital debris and been damaged, but we've had some close calls.
Objects, no matter what their size, are always in danger of being pulled out of their orbits by orbital decay. Orbital decay occurs when an object loses speed caused by friction and begins to be pulled towards Earth by gravity. Atmospheric drag is the major cause of orbital decay, like a bicyclist on the road.
When you're pedaling along at a constant speed, you're balancing your muscle power against the drag on the tires from the road and the resistance of the air that you're moving through. And you overcome that resistance on the bicycle with your muscles, or in space by firing your rocket engines to add a little speed and overcome that air resistance. That's what has to happen in space to keep the space station from falling back to Earth and burning up. And if you stop adding thrust, that air resistance will eventually slow you down to the point where you'll stop or fall back into the atmosphere and re-enter.
Some pieces survive re-entry. And the size of these pieces that have fallen to Earth is terrifying. In the last 40 years, 17,000 pieces of space debris have survived re-entry.
Back in 1997, we had a 570-pound stainless steel tank that landed about 50 yards from